some Java coding. So we'll be looking into variables, data types, operators, typecasting, and then we'll also look at how you can take standard input and output, or you can take input from the user and give standard output to the user. Just before we get started, a quick reminder that you can find this course in newtonschool.co as well. The link to Newton School will be given in the description for the video. So if you come to this particular link, you will be coming into this homepage. You can register to Newton School by either signing up if you're a new user, or log in if you're an existing user. Once you have logged in, you will be able to see your own dashboard. And to search for this particular course in the dashboard, look at under more tracks. There, search for Introduction to Java and OOPS. In case you're not able to see the tile at the first shot, please click on Load More. You can apply for the course here, and once you are able to finish, and once you have completed this this course, you will be given a certification. As well as, in case you want to follow up with the assignments that we will be doing, you can also follow the assignments from here. So if it's interested users, please do come to newtonschool.co, which the link to which will be given in the description, and you can sign up for the course here. Okay. Now going directly into the course. So as I said, we will be doing mainly building blocks of Java today. That is, we'll try to understand what are the basic things, or what are the building blocks that are needed for you to start your coding journey in Java. So what we'll initially be looking at are variables and primitive data types. Now, at a very high level, if we need to define what exactly is meant by a variable, so variable is nothing but a container. It is a named container for storing values or data. So if you want to store some kind of a value and you want to use that value later somewhere in the code, variables are what you need to use. So whenever you are declaring a particular variable, some memory is allocated for it. So what I mean by memory is allocated means, so assume you want to create a variable which can store the name of a user. So when you want to store the name of an user, some memory will obviously be needed, like based on how big the name of that user is. So some memory will be allocated for you, and in that memory location, you can keep the actual value. And the value is nothing but the name of the user. And depending upon what type of variable you're creating, that is, whether your variable will contain a string like a name, or whether your variable will contain an integer value like something like, let's say, the age of a user, or your variable may contain something like let's say the average marks of a user, that let's say the average mark that a student has received. So that's going to be a decimal point value. So depending on what type of data you want to keep in your variable, that amount of memory will be reserved for you. And one thing to note here is, whenever I say memory, I do not mean the secondary storage. That is, I do not mean the hard disk of your device. Rather, I'm talking here about the primary storage, which is the RAM. That is the random access memory of your CPU. So whenever you're running a program, your program is loaded into the primary memory, which is the RAM. So if you say that you need to store a variable, the memory will be allocated in the RAM itself. Now that we know what exactly is meant by a variable, trying to understand what data types is, it is pretty closely related to variables, because as I said, that whenever you want to declare a variable, that is, whenever you are working with a particular variable, that variable must have a type associated with it. That is, what is the type of that variable? Like, are you going to store a simple number? Are you going to store a long number? Are you going to store a single character? Are you storing a decimal point value? So based on that, the type of the variable will differ. And this is known as the data type. That is, what is the type of the value that you are storing. Now, if we go deep into data type, we will understand that there are actually two types of data types. First is known as the primitive data type, and another is known as the complex data type. So for this video, we will only be concentrating on the primitive data types that Java has to offer. In one of the future courses, that is probably in module 4, we will be looking at some of the complex data types like strings and arrays which Java has to offer and how you can operate on them. So now trying to look into what are the primitive data types that we have. So I have prepared a chart here. I'll also be sharing along with this video a particular link, which is where you can also see in more details about what are the primitive data types which are available in Java and what are they used for. So I'll go via some of them only. I will not go through all of them because not all of them are kind of used regularly. So things which are used a lot, something like int data type. So int data type is the most popular data type if you are storing integers. And when I say integers, they cannot have any decimal points to it. So if you want to store an integer or you want to use an integer in your code, then int is one of the most the popular data types that you can use. Next column is giving you the size of the data type. So size of the data type has been given in terms of bytes. So in computer science, memory is always calculated using bytes and bits, where kind of 1 byte means 7 bits. So here, if I'm storing something like 4 bytes, so then you can do the calculation as to how many bits you are actually storing. So integer, the default value of that will be 0, and the maximum value will be, then the value range will be between minus 2, 147, 483, 648 to this number. So any number which is falling within this range. So if you're trying to store a number which is falling in this range, then integer is the right kind of data type to store that value. If your number is not falling within range, if it is going outside of this range, then you probably need to think of some other kind of data type which can be used to store that kind of value. But as I said, since this is a pretty big range, most of your integer needs will be solved by int. The next most used data type is long. Long is a bigger version of integer, and as you can see, the size almost doubles from 4 byte of an integer, it becomes 8 bytes, which actually means almost 64 bits. So if you are trying to store a number which is bigger than this range, probably long is your next best option that you have. And in the and here I've given you the range also. So minus 2 to the power 63 to 2 to the power 63 minus 1. This is the range. This many. So if your value is falling within this range, which is actually pretty huge, you can use long. But general thing is that you should always use int unless you are expecting that the input that the user will give or the calculation that we will be doing will exceed this particular range. The next most used data type will be double. So double is again 8 bytes, same as long, and this is used for storing decimals. So if you want to store double precision decimal values, then double is the best place. So some examples of decimals would obviously be like, let's say you are storing the average marks of something, or let's say you are doing some mathematical operation and you are trying to find out the exact probability. You are trying to divide two numbers, then double will be the best place, because if your answer is going to contain decimal points, then double and float should be considered. Now, float and double both are used for storing precision variables, that is decimal type variables, but float is of a shorter size than that of double. Next is Boolean, which is just 1 bit. So Boolean's value can only be true or false. So in case you want to store, true false data, so when I say true false data, so example would be, let's say you are storing the data for a user and you want to store whether that particular user can cast vote or not. So based on the user's age, you need to decide that whether the user can cast vote or not, right? So if your variable can have an answer like true or false, like for in this example that I gave, that whether a user can vote or not, if you want to store a variable containing the data, then Boolean is the best place to do that. And char means character. So if you can represent a single character, it is of size 2 bytes. So one single character like A, B, C, or D. So this kind of single characters can be stored by char. Now, I generally find this kind of a mental map for remembering what kind of data type we should be using. So as I said, the first data type, first thing, the data types are divided into 2 types: primitive and non-primitive. Primitive, in case we're trying to store Boolean, that is, you want to store true false values, then Boolean is the best thing. If it is of type numeric, then there are 2 options: whether you want to store a character type variable or an integral type variable. If it is character type, then car is the best format. If it is integral, again you need to check 2 things: whether it is a decimal, whether there is a decimal point in your variable, or whether it is an integer. Then based on the size of your integer, you need to choose between byte, short, int, and long. And as I said, int and long are mostly used. And if you're storing floating point, then between float and double. Here also, mostly people do work with double. But in case you are trying to do some memory optimization, because as you might have seen in the earlier slide, double is almost double the size of float. You can try to use float also, depending on how much precision you really want in your system. So these are the data types that are, or rather the primitive data types which are available in Java. For non-primitive data types, as I said, we will be covering them in a later class. Now we'll be going directly into the demo. So yesterday, when I give the demonstration of setting up Java and building a simple Hello World project, I used Visual Studio Code, VS Code for doing it. Today, I'll be showing you a different kind of ID, which also you can use for doing coding. So for that, I'll go back in the Newton School site and let me just log in. Okay. Just give it a second. Okay, probably I'll try to just. Okay, I think we are facing some issue with the site. So probably we will come back and show you the operations of the site later. So maybe for this particular video, I will go ahead and I'll continue with the demo in VS Code itself. So in tomorrow's class, we will try to solve this problem, and we will go ahead and show the. I'll show you the ID that is present in Newton School and how to use it. Okay, let me go to Visual Studio Code. It's opening up, and it is opened up. So yeah, so this was yesterday's program that we did, just a simple hello world kind of a thing. So today we'll be looking into the different, we'll create a different class, and we will be doing today's demo there. So again, I'll create a simple file, and just for the sake of it, let's call the class today as, let's say, block building, or let's say BB, building block. Okay, building block with Java. So yeah, so this created the basic class. Now let me create the main program. Okay. The main program, as I said yesterday, it is a starting point of any program in Java. So whenever a Java class is running, so it looks for the compiler looks for the main program, and from this is where kind of your execution starts. Okay. So first thing today that we will be looking for is about variables and how we can declare variables. So let's go ahead and simply declare a variable, and we'll be using and we'll be creating an integer type variable, and let's call it as num1. So this is as simple as that. So if you introduce a line something like int num_1, what you have done is you have created a variable called num_1. So in the RAM where this program is running, and by the way, this will happen once the program starts executing. So when the program starts executing, in the memory in RAM, memory will be allocated, and how much memory will be allocated? 4 bytes will be allocated, because size of int is 4 bytes. So 4 bytes will be allocated, and that allocation will be reserved, and that name of the allocation will be num1. So that is what is meant by this particular line. That is, a memory will be reserved for you in the some memory will be reserved for you, it will be allocated for you, and that memory allocation name will be num1. So you can access that allocated memory by num1. Now we can do something like this as well. Num1 common num1 comma num2. What this means is that not only one variable, but here two variables, num_1 and num_2. These two variables has been declared, and when the program is running, two memory locations will be allocated for this program. One will be called num1, another will be called num2. This is what is what is meant by this particular line. One thing to notice here is that currently we have only declared the variables. That is, I'm saying that, simply saying that, hey, please go ahead and allocate some memory in your primary memory and call it as num1 and num2. We haven't assigned any value to it. So this is known as declaration. That is, I'm simply declaring some variables. I'm yet to assign values to the variable. So now the question comes is, okay, how can I assign some value to this variable? Currently, because num1 holds nothing, it is just a reserved, it is just a name of a reserved memory location. It doesn't have any value. So the way to do that is pretty simple. I call something like num1 is equal to 1. And I say something like, let's say num underscore 2 is equal to 10. What this means now is that value of one of the previously declared variable, that is num1 was a previously declared variable. Now the value of that variable has been assigned. So in this line, when num1 or when a memory location was reserved for num1, in that memory location, a value called 1 has been kept now. Till this line, that memory location was empty. There was no values there. But from this line onwards, that memory location has a value, and that value is 1. And similarly, num2 is equal to 10, which means that that the value here, that earlier whatever was declared as num2, the value is now 10. Like whatever memory was allocated, in that memory, a value 10 has been kept. Another thing that you can do here is overriding the variables. Now, as you can see that the name of that is, we are calling it variable. So since it is variable, that means the value of this thing can actually vary. So if I write something like this, num2 is equal to 12. What it means is that earlier the value of num2 was 10, and now I'm overwriting the value, and instead of being 10 there, I'm overwriting that value. I'm erasing whatever was there in the memory for num2, and I am keeping a new value called 12 there. That is what is meant by this line. So this is known as overwriting. That is, you're overriding a previously assigned value for a particular variable. Another syntax that we can keep is something like this. Now, till now, what we saw was, we saw declaration and assignment happening on different lines and different times. That is, first I'm declaring a variable, reserving the memory, and then I'm assigning a value to it. But in Java, you can actually do that on the same line itself. So if I write something like this, this means that I'm creating a variable called num3, which means I'm reserving a space in the RAM for num3. And also at the same time, I am assigning that a value to that particular variable, or I'm keeping a value in that particular memory location. And what value I'm keeping? I'm keeping 15. So this kind of thing is known as initialization. That is, I'm actually initializing a variable. I'm not only declaring a variable, but I'm also assigning a value to it. So this is known as initialization. And what we did here, this was called declaration, this was called assignment, and this is called initialization. So it is, we're all doing the same thing, but in different syntaxes, and each of the syntax has got a particular name. So this is the way how you can declare variables, and you can keep a data type to it. So in similar fashions, if you want to create a long data type, you can do that as well. So I can do something like, let's say, long num4 is equal to probably a big number, something like this. So now a data type of num has of type long has been created. You can do double also. So I can do something like double, let's say, precision number. So pnum1 is equal to 1.1. So that means so here you can see that till now all the values that I was using, they did not have decimal points. They were precisionless. But this one has some precision. Look, I'm sorry. Yeah, this is going to be the syntax. So here I'm creating something like a double. In similar fashion, we saw other data types like Boolean. So I can do that also. Boolean val is equal to. Yeah. So I'm keeping a value. So I'm again declaring a variable called val, which is of type Boolean, which is a 1-bit variable, and there I'm keeping the value of true. So this is how we can declare variables. We can assign values to variables. And now what we'll see is how we can operate on these variables. Like we can do addition between variables, subtraction between variables, and stuff like that. So there are multiple types of operators which are available to you. And that is what we'll be looking at next. So we'll be just doing a very simple theory to understand. Okay, I'll come to typecasting later. We'll go ahead and look into operators first, and then we'll go back to typecasting. So operators are kind of like special characters, you can say, which are used to operate two variables or operate on two values. Now those values can be direct constants or they can be variables as well. So we have various types of operators based on the way they are used and what kind of operation they do. Unary operators means that they operate on a single variable. Okay, that is, let's say you have declared a variable called a, and you just want to increase the value of that variable by 1. That is known as an increment operator. So those are what unary operators are used for. That is, it works on only one variable or one operand. Actually, that probably would be a better term. Arithmetic operators, these are operators which can work on multiple variables, and they do simple arithmetic operations like plus, minus, multiplication, division. Shift is a binary operator actually. So what shift underneath it, what it does is that it actually shifts the bit operation of a number to the right or to the left, depending on what kind of shift operator you're using. So if you're using a left shift operator, it is going to convert that particular number into its binary format, that is into zeros and ones, and it is going to shift it towards the left, that it is going to add 0 at the end. And the same thing happens with the right shift operator as well, that it will shift the values to the right, that it is, it will add a 0 to the beginning of it. Our next thing are relational operators. So relational operators are used, as the name sounds, to build relationship between two operands or between two variables. So this means it is the lesser than sign, greater than sign, lesser than equal to, greater than equal to, whether they are equal to or not, whether they are not equal to. So if you have got two variables, let's say one's value is 15, another value is 10, and you want to create a relation, or you want to check that which variable is bigger. So for this, you can use the relational operators. Like if you have two variables called a and b, and you want to check whether a is bigger than b, you can do a relationship like a greater than b. And the answer of a relational operator is always going to be a Boolean. That means it is always going to be either true or false. It cannot be anything else. Next are the bitwise operators. So bitwise operators, again, like they will do bitwise operators. So if you have got two variables and two numbers, it is going to convert them into binary, and then it is going to do the bitwise operation on them. So if you give something like or ampersand, then people, if you're familiar with how bits work, then it is going to do the bitwise calculation of those two variables and then give you the result. Logical operators, they are used to connect two relational operators. Like for example, you want to check, you want to create a relationship between two particular relational operators. Like for example, if you have got three variables a, b, and c, then you need to and you have been given a problem that what you need to check whether a is greater than b and c. So using relational operators, I can create that a greater than b. I can also create a greater than c. But here you have been told you need to check whether a is greater than b and a is greater than c. So how do you create a relationship between these two relational operators? So this is where logical operators come into picture. So you can say something like a greater than b and ampersand ampersand a greater than c. So and is represented by ampersand ampersand, or it's represented by 2 bars. Ternary operators will be covering this in tomorrow's class, because when we'll be doing if-else conditions, so I'm not going to dwell on it. Assignment operators are for assigning a value to a particular variable, equals to, plus, equals to, minus, equal to. We will take a look into details about the assignment operators during the demo. Okay, so we will go back to the demonstration. So we will start with very simple. We will start with summation. That is, we'll start with arithmetic operators. So let's say I have these three variables. Let me keep num3 here as well. And I want to create, and I want to add these three variables. I can do something like integer sum is equal to num1 plus num2 num3. So what I'm doing here exactly, I'm taking the value of num1, adding it with num2, then adding it with num3. So it will be 1 plus 12 plus 15. And now if I want to see the result, that is, I want to check, okay, what is the value of them? Then from yesterday's class we saw we can do something as simple as system.out.println, and inside of it I can pass the value of sum here. So now if I again run this application, and yesterday we saw how we can run it, I'll do run without debugging for now. declared package. Okay, sorry, right, because I need to declare the package name, which I did not today. My bad. I hope this works. Let me run it. Yep, 28. So that is what comes up here. That is what the value comes up here. So it is adding the value of num1. It is adding it with num2, num3, and then it is taking the value of sum, and then it is printing the value. It is printing the value of sum. Now let us take a look at another operation. Like let's say instead of plus, if you want to do multiplication, you can do that as well. So I can do int mult is equal to. So let's say I take num2 multiplied by num3, and again if I need to print it, I can do that. Mult, and now if I run it, yeah, this is going to run it. So first was 28 and second was value was 180. So it did something like 12 into 15, and the answer that came up was 180. All right, that's fine so far. Another operator I'll just show you, which is known as the remainder operator actually. So this is so remainder operator is something which is actually used to check whether so if you're dividing particular two values, it will check that what will be the remainder of it. So let's say I do num3 modulus. So this is known as the modulus operator, which actually checks the remainder of num2. And if I again print this value, we'll see the answer, and then I'll explain how exactly that is coming up. Yeah, the answer came up as 3. So you see what happened there was num3, which is 15, and num2, which value was 12. It did a 15 modulus 12. What it means is that if you divide 15 by 12, what will be the remainder? So if you divide 15 by 12, what will happen? 12 into 1 is 12. So 15 minus 12 is 3. So that extra 3, that is the remainder here. So that is what modulus is actually going to do. So modulus is also a very important operator, and for some tricky programming logic, you will be requiring the use of modulus, especially if you're doing digit programming and stuff like that. Then modulus really comes into handy. Okay. The next thing that we'll be doing is about typecasting. That is, we'll be taking a look at what exactly is typecasting and how you can use it. So let me go to typecasting. So typecasting really means that if you've got a variable in a particular data type, you can change that to a different data type. That is, you're assigning the value of a primitive data type to another data type. So first thing is, so there are two types of typecasting that you can do. One is known as widening and another is known as narrowing. Widening means you take a data type which is a smaller size and you assign it to a data type which is a larger type. And this happens automatically. So if we again go back and take a look into the sizes of these various data types like byte, short, integer. So if I take a value which is of type byte, that is which is represented by a byte data type, and I say I want to assign it to integer, there won't be any issues, because if you see the range, then byte has got a range of minus 128 to plus 127. So any number between this range can be represented by a byte. Now, int has got a much bigger range. That is, its minimum value and maximum value is much larger than that of byte. So it means any number which can be represented by a byte, that is, which is in between these two values, can definitely and easily be represented by an integer. So if you change the value, data type of a value which is of type byte to integer, that means you are simply widening the scope. So that kind of typecasting is known as widening. So here we have given kind of like a flowchart kind of a thing, which will tell you like which data type to which data type. If you are changing, it becomes normal natural typecasting or natural widening. So byte to short to character, character to integer, integer to long, long to float, float to double. If you are going in this path, that is, you are trying to convert a byte to an integer, or if you're trying to convert an integer to a long or a float to a double, you are simply widening the scope, and there is not going to be any issues there, and it can be done very easily. Now, the other thing that we will be looking at is called narrowing. So narrowing means that you are narrowing the scope. That means from a larger size data type, you are converting it into a smaller size data type. Now, this is something that cannot be done naturally. So because if you think of it metaphorically, you are taking something which is of larger size and you are forcing it into something which is of smaller size. So what will happen? Like, let's say if you have to think normal physical in a physical world, if you take something which is of larger size and you are trying to fit it into something which is of a smaller size, how do you do it? You have to remove some parts. Probably you need to cut some part of it so that it becomes the same size as that of the smaller container, and that is how you can push it. So when I say you take a bigger object, cut some portion out of it, and then put it into a container of a smaller container, you're losing something, right? You're losing some parts of the original object that you had in the bigger container. So this is where if you try to narrow the scope of a particular data type, there can be some data loss or there can be some precision loss that might happen. Like for example, let's say you have got a number which is represented in double, which is called, let's say, 100.1. Now you are saying that 100.1, which is already represented in double, I want to represent it in integer. Now, what is the difference between double and int? Double can have decimal points, int cannot have decimal points. So if you force something like 101, a value called 101, which is of type double, into an integer, into a type int, what will happen is from 101, it is going to become 100. So what happened here? The decimal point was just dropped because you forced a bigger number or a bigger data type, a double, into something like integer. So this is where precision loss or data loss actually happened. And since data loss can happen, and this is not a very natural thing, you have to do it manually. You need to forcefully convert. You have to forcefully convert let's say a double to an integer. You need to forcefully do it. So in a lot of places, this is also known as coercion. That is, you are kind of coercing the data type to be narrowed, the scope of the data type to be narrowed. So we will just go ahead and take an example of actually what exactly I mean by that, and we'll be doing it in practical terms itself. Okay, let's take this example. So what I'm going to be doing is I'm going to be declaring two double variables here. Let's call it as double p num1, whose value, let's say, is 10, and I'll be doing a double p num2, whose value will be 12, and then I'm going to be dividing them. So double, let's say I call it as diff, and I do p num2 divided by p num1. Sorry. And if I try to again console this result, and let me comment these things out because I'm not going to be using them anymore. Right. Let me run this. So the answer was 1.2. 12 divided by 10, it's very simple mathematics, it is 1.2. Now let us try to do something where I'm going to be doing a coercion. That is, I'm going to say something like integer, I'll call it as, let's say, idef is equal to int diff. See, this is the syntax of narrowing. That is, I know div, that is diff, is a double, but I'm forcing it to be part of an integer. So to do that, I need to give a syntax like this. That is, if that is just before the variable, I need to put in brackets what is the destination type that I want. That is, if I'm changing the data type of this particular value into what destination type. So what I'm saying, I'm taking a value diff, whose value, as you know, is 1.2, and I'm forcing it into an integer. And if I type it and if I pin the value, the result should, let me just clear this out. Yeah, the result should be, you probably will just run it and see. First value was 1.2, second value was 1. And why did that happen? And the reason as to why that happened is because since we are forcing a decimal type variable, a decimal type value, which has got some values after the point, into an integer, which cannot represent a decimal type value, it is going to just simply drop whatever was after the decimal point. So from 1.2, it simply became 1. So that is what is known as data loss. So this is an example of where data loss actually happened because we coerced or we narrowed the scope of a variable. This also, like this trick that I also showed you, is actually is also a very useful one, and we will see in tomorrow's class when we will be doing some digit programming of how you can use these skills or how you can use this particular thing into creating doing some very intelligent programming. All right. So now we saw operators and we saw and then we saw some of the variable types. We will be just doing a few more type of operators that we discussed, something like the Boolean operators and binary operators and stuff like that. So Now let's see. I'm going to be declaring a variable called it's a bool whose value is true. Anyway, let me also comment this portion out because I'll not use it. Okay. So if I do something simple as system.out.println bool, what will happen is that just a value true will be printed. So if I run this, yes, a value true will be printed. So there is one unary operator that we can use here, and that unary operator is known as AND. So what I can, sorry, not AND, sorry, it is known as the NOT operator. So what NOT operator is going to do is, it is simply going to change the Boolean's value from whatever the original value was to its inverse value. So if I do something like INV is equal to not bool. So the term not here, it simply means this particular symbol, that is this exclamation symbol. So if you put an exclamation symbol in front of a Boolean value, it means I'm inverting the value. So if I now print the value of INV, so the answer is going to be, first it is going to print the actual value of bool, and then it's going to print the inverted value of bool. So the actual value of bool was true, the inverted value was false. The same is true if the value of bool was false, then it would have just converted into true. So let's show that demo as well. Yeah, first it was false, and then it got inverted into, from false it became true. Okay. Carrying on. We'll be looking into something called postfix operators and prefix operators as well. So let's again have two simple variables. Probably I'll be using these variables here again. Bring this guys here. Okay. So prefix and postfix, we'll be doing some incremental and decremental operators. So let's just show you exactly what is meant by incremental and decremental operators. So something like system.out.println will do plus num1. So what this means is that it is going to take the value of num1 and it is going to simply increment it by 1. Okay. So the value of num1 is 1. So ideally this output should actually be that is 1 plus 1, 2. So let's see, let's run this. Okay. Sorry for that compilation error. I did not comment out the previous code. Yeah, so value become 2. So here it was declared as 1, but here as you see the value become 2 because it got incremented by 1. Let me try to clear this out as well. Now this is actually known as prefix operator because I'm trying to increment it, or rather I've kept the unary operator, the incremented operator before the variable. I can do something like this also, that is num plus plus. This will also do the same operation, but there is going to be a simple trickery here, or there's going to be a very simple, a very small change. So let me try to output this and see what happens. The value is still 1. So it is as if that this plus plus did not happen. That is, the value is declared to be 1 and it is assigned to be 1 and it is still 1. So what exactly happened here? So to know that, probably I'm just going to be printing the value of num1 twice. First I'll do num1 plus plus and then I'm going to print only the value of num1. Clear this. Print it. Yeah, see, first it was 1, then it got printed as 2. So what actually happened here was, this is called postfix style of operating. That is where I am keeping the operator, the unary incremental operator, after the variable name. So what happens in a postfix operation is that the value will be incremented. That whatever variable I'm keeping, I'm trying to increment it, it will be incremented, no doubt about it. But that will be incremented after executing the current line. So after the first, it is executing this line and it said that, hey, I need to bring num1 and there is num1 plus plus. So it is going to first execute this line with the original value of num1, which is 1 here. And after this line has been executed, then before it can go to the next line, it is going to increment the value of num1 by 1. So when we come to the next line, then it is value is going to become 2. So that is how postfix differs from prefix. And prefix, what happens? Before the execution of that particular line can happen, the increment will be done. So in the same example, if I, instead of num1 plus plus, if I give something like plus plus num1 and I try to run it, you will see the difference. In both the cases, it was 2. Because here I did plus plus num1. So num1's original value was 1. First, it was incremented to 2. Then this particular line was executed. So here you can see the difference. In postfix, it was 1, 2, and in prefix, it was 2. Now the same things can be done with minus minus also. Minus minus means it is going to be decremented by 1. Plus plus means it is going to be incremented by 1. So I'm not showing an example of minus minus. I'm sure that you folks will be able to manage that. I will go into the next type of operator, and this time I'll be showing you some of the logical operators. So logical operators means you want to, do some, you want to relate two particular, sorry, we'll be showing relational operators first. That we want to relate to operand here. So as I said, relational operators, the answer of or the output of a relational operator is always going to be Boolean. So probably I'm going to give res, and I will do something like num1 greater than num2. So what this particular line means is I'm checking whether num1, the value of num1 is greater than num2. If it is greater than, then the answer will be true. If it is lesser than, the answer will be false. So here, if I try to do something like, let's say system.out.println, yes, what should be the answer? Is num1 greater than num2? It is not. Num1 is 1 and num2 is 10. So 1 is not greater than 10. So ideally, the answer should be false. So we will check that whether that's what it works or not. Yeah, it became false. And instead of this, if I had given a symbol like this, that I will check that whether num1's value is lesser than 2. Yes, 1 is lesser than 2. Then the answer should have been true. So again, let me execute this. I don't know this message here. Yeah, true. So yeah, so it is working. So this is what is known as kind of logical operators. Now let me show you something called relation. Sorry, this is relation operator. Now let me try to be logic around it. I'll be creating another number called num3, and probably let's call it as res1, and I'll have another result here, result 2, and result 2 will be, let's say I kept num2 is greater than num3. Okay. So I have two relations created here. First relation is num1 is lesser than num2. Second relation is num2 is greater than num3. So first one, num1 lesser than num2, as we saw, it is going to be true. And second relation, I'm checking whether num2 is greater than num3 or not. So num2 is 10 and num3 is 15. So 10 is not greater than 15. So this one's answer will be false. So res1 will be true, res2 will be false. Now let me just show you if we have to link this two. So we will be doing again something like Boolean. Res3 will be equal to res1 and res2. So what it means is that the value of this Boolean result 3 will be true if both res1 and res2 are true. That it is checking if both the conditions are true or not. And if I write a condition like this, Boolean res4 is equal to res1 or res2. So this is what I'm checking. What I'm checking is whether res1 is true or res1 is true or res2 is true. So if either one of them is true, then res4 will become true. So if we simply try to print it now, I'm pretty sure you guys should have guessed the result by now. What will happen? So I print res3 and I print res4. And what's going to happen is first one will be false, second one will be true. Why is first one false? Because here it is checking if both the conditions are true, and it is not true. Res1 is true, but res2 is actually false. So that's why it is given, since both the conditions are not true, one of the conditions is false. That's why res3 has become false. But why is res4 true? Res4 is true because you are checking here either res1 is true or res2 is true. That is, you're checking if either of the result is true, then I'm good with it. And here, as we saw, that res1 is already true, but res2 is false. But since one of the result is true, res4 became true. These kind of relational operators and the logical operators, they become very important later when we will actually be doing conditional operators and stuff like that. That is when we'll try to write basic conditions, like you'll be taking some input from a user and you will be checking it against a particular condition and then processing some data or processing some work and everything. So at that place, logical operators and relational operators, they become very important. And in tomorrow's class, when we will actually be doing conditionals, we will be seeing how we can actually exploit these relational operators and logical operators to write complicated pieces of code. Alrighty. I think we are done with most of the operators. One last operator that I wanted to show you is something like assignment operator. So assignment operator simply means that you are assigning some value to a particular per a particular variable. So we already did actually assignment operators, because every time we're doing equal to, we are actually assigning a value to a particular variable, right? So a single equal to is actually an assignment operator. You are doing some sort of assignment operator there. Then also we saw the inversion. So yeah, I think, where did we see inversion? Yeah, here when we saw inversion here. So inversion was also a type of assignment where you are actually kind of inverting a value and then assigning it. So this is actually unary in nature, but you can, but this is a type of assignment itself. So for assignment, I'll be showing you a very interesting demo here. So let's call it as, I think I'll go to num5 is equal to 7. And what I'm going to be doing is I'm going to write it as num5 plus equal to 3. Okay. And I'll simply pin that. So the answer for this should actually be, sorry, done this 10. So what exactly this line means is, so just in a comment, I'll just mention what this line means. It means num5 is equal to num5 plus 3. This is what this statement means. That is, you're taking the value of num5, adding it with 3, and then assigning it back to itself. So it's kind of like a self-assignment kind of a thing, you can say. So in other words, you're taking the value of taking a variable and you're incrementing it by a particular value. So when we did plus plus and minus minus, when we were doing this kind of incremental operators, here you are incrementing it only by 1. But if you want to increment it by something greater than 1, something by a particular value, you can use something like plus equal to, because this line means that. In similar fashion, you can also use something like, let's say num5, maybe comment this out, minus equal to 3. What this means is it is going to take the value of num5 and decrement it by 3. So if I do if I compile this, and the answer should actually be 4. So here, because I'm taking 7 minus 3 is 4, so that is where it comes. So you can do plus equal to, minus equal to, multiplication equal to, divided by equal to, all these things you can actually use. You can even use, so when I showed you this one, modulo operator, that is you're trying to check the remainder. You can do that also. You can use the modulo operator also on itself. So these are also some types of assignment operators that you can use. So in this class, we saw some of the building blocks like variables, data types, how to use variables, how to do typecasting between variables, how to use operators, logical operators, arithmetic operators, relational operators, some of the binary operators as well. Now, before we end the class, I would just like to talk about another simple thing, that is, we'll be talking about how you can take inputs. That is how you can work with inputs. Currently, all that we have been doing is we are actually outputting data to the user, right? Now, what we will see in very shortly is how you can take input from the user. That is how the user who is actually using your program, who is your actual end user, we call them as, how will they enter data to your code? That is if you want to take some information from the user, how you can actually do that. So output and input. Output we already talked about. So we mainly did system.out.println. There is something called system.out.print as well. The difference between system.out.print and println is print will simply print whatever has been given to it. And what println does is it is going to print whatever has been given to it and then take the cursor to the next line. So next time when you print, it will be printed on a new line. So maybe probably we'll do a very small demo to give that example of, to show how it works. So if I do something like, let's say system.out.print, and I give here ABC, and I again do a system.out.print, and I'm going to do DEF. Now, if I do this, and if I run this, what will happen is, if you see the output carefully, ABC, DEF, they both got printed on the same line. Because after ABC, the cursor never moved to the next line. It stayed where it was. And then I'm saying print DEF, so it again printed there. Now, instead of that, if I make the system.out.println, let's just see the difference. The difference here will be ABC will be printed in one line and DEF will be printed in the next line. Why is that happening? Because I made it system.print.ln ABC. That is, after printing ABC, the cursor actually went to a next line and was waiting for the next thing to be printed. And the next thing that got printed was DEF. So here we got DEF got printed. Okay, that's the difference between system.out.print and println. And then you've got something called printf as well. So printf means if you're trying to format the string that you're printing, that is what it is used for. I'll not be discussing in details as to string formatting in this class. There is a link that I've given in the PPT. It will be shared in the video as well, where you can go and understand about what is meant by string formatting and all the formats and everything that is available to you. Next, very quickly, we'll be looking at how you can take input from the user. So in Java, there are multiple ways of taking inputs from the user, and probably in some data classes, we'll learn about a few more things like buffer feeders and stuff like that. For now, we will be looking into a very basic package known as scanner and how we can use scanners to take input from an user. So without, again, I don't want to go into very details about what is meant by a package in Java, but you can understand package is a bundle of multiple utilities and multiple code. So if you bring, so let's say if you're writing a particular utility, if you're writing a particular piece of code and you want your code to be shared, that is, you want your code to be used by the next person or someone else, what you do is you take your code, you package it, you give it a unique name, and then you give it to the other person or other coders who want to use your particular code. So similarly, scanner, that is java.util.scanner, is actually a package which contains a lot of utilities which is used in Java. One of the utilities is the scanner itself, which is used for taking inputs from the user. Okay, and I'll be showing you the syntax of how this is actually used. So first thing that you need to do is you need to import it. That is, you need to import that particular thing. So if I again go back to the thing, you'll see it is java.util.scanner. So here it is, java.util.scanner. This is what I need to import. So probably I import that java. Util dot scanner. Okay, done. So now I have imported java.util.scanner. Next thing that I need to create is I need to create an object of type scanner. So scanner input is equal to new scanner, and I need to pass a stream here. So I'll pass system.in. If you're getting confused with the syntaxes, I would say do not worry so much about it. We are creating an object, and in later classes we'll understand what are classes and objects. So for now, just take them as syntaxes. But ideally, what is happening is you're creating an object of type scanner. That is what is happening in this particular line. Okay. Now let us take an input from the user. So what I'm going to do is first let me print a message, and in the message I'm going to say this is system.out.print enter a number. Okay. And just if you see, I did a system.out.print, not a println. Okay. Next thing is I need to take the input, and to take the input, it is pretty simple. I do it's a number is equal to input dot next int. Next int means from the console, I'm expecting the user to give me an integer. Instead of next int, had I written something like, let's say, next double, this means I'm expecting the user to enter a decimal point for me, not an integer for me. And by the way, this line is going to give you an error because you're trying to store a double into an integer. And as you know, you cannot store a double into an integer until you typecast it. So anyway, I'm not going to do that. I'll give it simple. I'm going to do just, next int itself. Okay. And maybe I'll simply print it out once, system.out.print. You entered number, whatever the number was. Okay, so a pretty simple thing, and if you want, you can actually go ahead and close it as well. That is, I'm closing the input class. This one is again, it's actually good practice. It's optional in nature, but it's actually good practice to clean up your code after clean up your program if there any memory allocations, stuff like that. So the close is going to do that. So now what happens if I run this? Enter a number. So I will say I'll enter a very simple number 12 and press enter, and I say here you entered 12. Now if I try to do a little complicated with it, that is, let's say enter number 1, and I'm going to do enter number 2, and I'll keep it in two places, number 1 and number 2. Okay, so I'm entering two numbers, and then I'm going to go to is int sum is equal to number 1 plus number 2, and I'm going to be printing sum, and in sum I'm going to print summation. Okay, is equal to sum. So if I do this, see what happens. Okay, let me clear this again. So I enter two numbers, 12. Now let's say the second number I entered is 10. Summation 22. That is, it did 12 plus 10 and it did 22. So this is a very simple program where you are actually interacting with the user. That is, you're asking user to enter some data, you're taking the data, processing the data, and then you're giving the result to the user. So this was a very, very simple program where you can actually start interacting with the user. So now that you know how to do inputs, how to push information back to the user, how to use variables, data types, and then you can do operators between them. So you should be able to do some complicated programs. You should be able to start a little bit of coding. So this is what I'm going to suggest to all of you who are watching the video. So once this video is over, please go ahead and try to write a very small piece of code, which is going to take some input from the user, do some operation, whatever you want, and then give a result back to the user. So try to write a very simple program, which is going to be, which will do that. So with that, we have come to an end to this video. So again, I would like to thank everyone for being part of the video and watching this video. And I'll just take some moment to see whether there are any questions that has been posted in the live comment or not. Okay, I think there was some comment about the increase of the font. Okay, I'm sorry about that. I did not realize that the font was really small, so sorry about that. So from next class onwards, I'll take care of that. So thank you, Rahul and Aman, for that particular feedback. Okay. I do not see any other question so far. So probably we will call it a day today. So again, thank you everyone who were able to join this particular session. I hope you learned something. And if you have any further question, I would suggest you to put those questions in the comment section of the video, and we will get back to you. Also, if you have any feedback about this video, about how we are doing it in the course, whether we are going too fast, too slow, or do you think we should cover more advanced topics and stuff like that, I would encourage you to put it in the video. So with that, once again, thanks everyone for joining, and probably we will see in the next class where we'll be looking into conditions and we'll be looking into looping. Thanks.